Hello everyone, welcome for watching our Engineering Statistic presentations video. We are come from Section 4 Group 1. Our lecturer is Dr. Chu Chang-chun. These presentations will be presented by 4 members, which are Yong Wei-Tings, Li Ziying, Chan Zilei, and Ki Yong-hyun. Our project title is Analyzing the Impact of Number of Reactors on the Total Net Electrical Capacity. Hello everyone, my name is Li Ziying. Now I would like to start the presentation with the introduction parts. For this assignment, our data is related to the nuclear reactors. Therefore, our topic is analyzing the impact of number of reactors on the total net electrical capacity. Objective of the study is analyze the relationship between number of nuclear reactors and total net electrical capacity. Number of nuclear reactors is our independent variables, and the total net electrical capacity is our dependent variables. The methodology that we use for this assignment is simple linear regressions, and the data source come from 30 countries. The topic data we study come from these 30 countries. So, what is the regression analysis? Regression analysis is a statistical method to model and analyze the relationship between variables. So its purpose is predict one variable which is dependent based on another independent variable. It is help in predicting and decisions making. Next, application of regressions in this study. The methodology that we use for this assignment is simple linear regressions. So it is used to analyze the relationship between the number of reactors and the total net electrical capacity, and also predict the electrical capacity based on the number of reactors. Next, the key components of regression analysis in this assignment. First step, find the regression lines, which is best fit straight line minimizing residuals. Second, regression equations, which is the formula y equal to ms plus c. Third, find the coefficients of determinations r squared. Measure the model accuracies, which is higher r squared equal to better predictions. Fourth, hypothesis testing is check if the relationship is statistically significant. Fifth, Pearson correlations coefficients. Measure strength and direction of the relationship. The software used for this assignment is Microsoft Excel.
Good morning, Doctor. My name is Yong Wei-Ting with metric number AE2200885. In this slide, we are going to analyze a table showing the number of reactors and the total net electrical capacity in megawatts for 30 countries. We use Excel formula to find the minimum, maximum, mean, and standard deviation for each variable. For the formula we inserted into Microsoft Excel can be referred in the slide given. Next, to make a linear regression graph in Microsoft Excel, if we need to quickly visualize the relationship between two variables, draw a linear regression chart. First, select the two columns with our data including the headers. Secondly, on the Insert tab in the Charts group, click the Scatter Chart icon and select the Scatter thumbnail. Now we need to draw the least square regression line where x is an independent variable and y is the dependent variable. On a regression graph is the point where the line crosses the y-axis. B is the slope of a regression line, which is the rate of change for y as x changes. Epsilon is the random error term, which is the difference between the actual value of a dependent variable and its predicted value. After done the previous slide graph, right-click on any point and choose Add Trend Line from the context menu. On the right pane, select the linear trend line shape and optionally check Display Equation and display R-square value on chart to get our regression formula y equals to negative 1778.73 plus 991.87x. As I noticed, the regression equation Excel has created for us is the same as the linear regression formula we built based on the coefficient output. Switch to the Fill and Line tab and customize the line to our liking. For example, we can choose a different line color such as red color and use a solid line instead of a dashed line. Check the significance alpha equals to 0.05 of the simple linear regression model in C. On the Data tab, in the Analysis group, click the Data Analysis button. Select the regression and click OK. In the regression dialog box, configure the following settings. Select the input Y range, which is our dependent variable. In our case, it's total net electrical capacity in megawatts, which represent E1, column E31. Next, select the input x range, which for our independent variable is number of vectors, which represent d1 colon d31. Click OK and observe the regression analysis output created by Excel. This part tells us how well the calculated linear regression equation fits our source data. The multiple arm measure the strength of a linear relationship between two variables, ranging from -1, which means strong negative, to 1, which means strong positive, with 0 indicating no relationship. R square show how well the model fits the data, with 0.97 meaning 97% of the variance is explained. Adjusted R square, refine R square for multiple variables, while standard error measures the precision of prediction, with smaller values indicating higher accuracy. The ANOVA section assess model variability, including df, which is degree of freedom, ss is sum of square, where smaller residual ss is better, and f is test model significance. Significance f is represent p-value. If significance f is below 0.05, the model is statistically significant, otherwise consider revising variable. Moving to this slide is the question about interpret the meaning of intercept and slope in this problem. Please comment any impossible event. In my opinion, for every additional reactors, the total net electrical capacity increases by about 991.87 megawatts, showing a strong positive link between the number of reactors and the output. On the other hand, the intercept of negative 1778.73 suggests that if there were no reactors, the electrical capacity will be negative. But it doesn't make sense in our real life, since capacity can be less than 0, while the slope gives the meaningful insights into how each reactor contributes to capacity. The intercept is just a mathematical result of the model and doesn't reflect a realistic scenario. That's all from me, thank you.
By referring this regression's output table, the intercept has a p-value of 0.0419, where it is lower than the significant level. Therefore, it can be concluded that the beta naught is not equals to 0. Next, the slope is statistically with a t-statistic of 30.8087 and with a p-value 3.81 times 10 power of -23. Since the p-value is far below from the significant level, so it is rejected hash naught, where the beta 1 is not equals to 0. To evaluate the regression model by assessing the regression model with 4 assumptions. First of all, the first assumption is residual variance are similar. Based on this graph, show that the spread of residuals are not constant and with higher deviations at the higher predicted value. Thus, this model is not satisfied this assumption. Next, the second assumption is residuals are normally distributed. The histogram of frequency against residuals showing a peak near to 0 but asymmetric. Therefore, the residual is not normally distributed even it is approximately normal. The model also assessed by the assumptions of residuals are independent of each other. Referring to this figure, it is no clear trend of the plot shown on the graph residual against observation. Therefore, it can prove that the residual are independent of each other. Last but not least, the fourth assumption is existence of significant outliers. According to this residual plot, it illustrates there are few residual deviating from 0 to indicate the existence of outliers.
Hi tutor, my name is Kiyong here. Right now I will continue the presentation. So this part is about the coefficient or determination and Pearson correlation. So Pearson coefficient is a statistic measure that quantifies the strength and the direction of the linear relation between two variables. And coefficient of determination is a measurement that indicates how well the independent variable explains the variation in the dependent variable. So in this case, my R is 0.9855 and R square is about 0.6242. So actually this indicate the R actually indicate that the data is a positive strong linear relationship and the R square is 69.43% closer to the regression line. Next is about the effect of outlier data point on the coefficient of determination. So obviously the data that we use is all of them is quite nearest to the line of regression, so we can conclude that the coefficient of determination is unaffected. Next is performance hypothesis testing to conclude whether linear correlation for the population rho and alpha 0.05 is significant, or not state the conclusion of testing. So first of all, we must set an assumption. So my hypothesis not obvious is rho equal to 0, and the alternative hypothesis is rho not equal to 0. So the alpha is 0.05 because the alternative hypothesis is not equal, so we need to use 2 tail. So the alpha must divide to 2, and level is 30 minus 2, which is n minus 2. So the final answer is 28, and after that we can using the t distribution table to find the value. So the value for this data is 2.048. Next is t-test. We can calculate the t-test using the formula that provided in the RPP, which is sub n minus 2 over 1 minus r squared. So the final answer will be 30.8. So we can obviously see the result that the t-test is much higher, much greater than the t. So we reject the rational hypothesis. So we can conclude that the significant linear relationship is exist between the two variables.
In conclusion, the regression model shows strong predictive accuracy with an R-square 0.971 and an adjusted R-square of 0.970, indicating it explains most of the variance in the dependence variable. The slope is highly significant due to it statistically with a t-statistic of 38.808 and a p-value of 3.81 times 10 power of negative 23. And the model overall significance is supported by a f-statistic of 949.18 with the corresponding p-value. Besides, the residual independence assumption is certified, confirming the model's validity and reliability in accurately predicting the dependence variable.